Thank you everyone for joining. Today we're building Solana NFT Indexer with using Yellowstone gRPC. So first of all, what is Yellowstone gRPC? It's low latency stream of on-chain events right from Solana. It uses Geyser plugin to stream for validator memory. About memory, actually, in a bit. It's a really interesting story for folks from Ethereum. So Yellowstone uses gRPC for high performance protocol real-time application. So what does it mean to be close to the source? You have a Solana blockchain on the top left corner, and it goes to your application to proceed with some event. For example, you have a trader bot that want to buy or sell something. And if you do high frequency trading, that's exactly the path this event will go. So first of all, block will be produced, block will be committed, then RPC indexer will index this block, then it will then your application will call RPC by yourself, and only then you will receive some information of purchase. For example, if you do copy trading, it will add overhead to your process. But with Yellowstone, you just get events straight from Solana directly with this Geyser extension. The biggest question, do you need heavy ETL? Because on Ethereum, you would likely have to do that. On Solana with Geyser plugin, you can subscribe only to what you need, so only to your account or account that you are copy trading, only to subset of transaction or exact program. For example, in a previous workshop from GetBlock, they track how PanFan coins are created and try to snipe the launches, as example. You can filter by account key, owner program, anything else, and you can combine multiple filters in the single stream. So you will not have overhead with everything that happens on Solana blockchain, only what you actually need for your application. So what you can do with that, first of all, I didn't mention it here on the slide, but it's about MEF. If someone knows what is MEF, maximum extracted value, this is what it's about. So you can watch wallet, react to its trade instantly, monitor program, which I covered before, and track token accounts. For example, NFTs, what we will do today. So difference between Ethereum and Solana is critical. On Ethereum, you have a mempool, which is some not committed parts of code that are being processed. On Solana, you have slots, and you don't have such a thing as mempool at all. So every single slot is the way how Solana communicate time between other nodes. So it's fixed time. It's about 400 milliseconds between each slot, and it could be either slot, so block on place of slot, or skipped slot. If not enough events or something happens like networking and stuff, it will be skipped. Idea is to have Solana slots to fit one epoch, which around 2 days, but because of skipped slot, it will not every single slot will be a block. And for Yellowstone in particular, you're reading for these slots, so the lowest level possible of Solana, and you have 3 levels of commitment, whether it's processed, confirmed, or finalized. The fastest one is processed, and finalized one is the most safest. It will most definitely will be committed to blockchain, and RPC relies on the latest one. So that's what Yellowstone gives you. First of all, it will make you having the least latency that could be, and also it will not wait for all these 31 blocks to be confirmed, and then only then you will have a data. With Yellowstone, you will have it immediately. So summarizing, slot is 400 milliseconds. Block will not happen every slot. At best, RPC users are 40 milliseconds behind Yellowstone users. In practice, it's like seconds behind, which is substantial if you do some. That's why MEF is possible. It's substantial to have Yellowstone if you're really into high-frequency trading. So let's go ahead to the workshop. I will share entire screen. And here again, the QR code for repository with workshop. I also send the link into the chat. So let's meet the project structure. We have README which contains information about the project, how to run it, and everything. And also, it has a lot of useful links. You can contact me in any way possible. I will always reply you. First, by GetBlock workshop that I mentioned about pump fund mints, and also nice video about epochs on Solana that explains it in the depth with schemas and stuff. So I wrote the test that we will implement today Indexer, and this test is coming for that. It's mocked Yellowstone. You connect with your Indexer with mock client, and you can make artificial events like minting NFT, transferring NFT, and slot updates. Test is the best way to explain how it works. So we will just track how many slots Alice had. So first, Alice minted NFT, then she transferred NFT elsewhere, and we should see that Alice was holding NFT exactly one slot. So we're building Indexer for MedLats NFT that will count how many NFT user held and how long did he held. And based on that slot time, which is perfect on-chain time, we will compute how many coins to allocate for airdrop for this user. So I will go ahead with boilerplate that I have for Indexer, and I can collapse this. So first of all, I mentioned before that the Yellowstone workshops most of time starts with reading real on-chain data, which is not the case if you're building own application. For example, you don't have NFT minted yet, and you want to build some infrastructure, so you will track it. So this workshop is more on building own application with Indexer, not high-frequency trading or something like that. So it's about own project. And you already know why it's important to be the fastest one, especially if it's your project. So I put Geyser client into interface. This is same as a real interface from GetBlock for Yellowstone gRPC. And this is Indexer. Indexer have some constructor, I will cover it later, that it gets Geyser client from constructor parameters. And we have run function that it's really simple. It's just open stream from client, you just subscribe, and then you set up handlers one after another, data, error handler, and on end of lifetime of subscription handler. And after that, you put write request to the stream to tell the application what you want to have in your stream. In this example, because we are building NFT indexer, we put mint information into the stream, so we will track only this particular NFT that we care about. This comes from constructor. So we have set of NFTs that we're tracking, and we are telling filter of Yellowstone to prepare only this type of data for us. It's very convenient. And we have commitment level, which is one of 3, either confirmed, finalized, and processed. Let's keep confirmed here. I mean processed to be the fastest one. That's it for boilerplate code. Now let's go into the details. So we have 3 methods on data, on end, and check allocation. On data will read events from Geyser, from Yellowstone, and on end will be finalization event of our indexer. So let's begin with update. Update, it has some different types of content, and for us, since we subscribe to account changes, we have account. So we have to check whether account is valid for our work. If not, we will just do early return. If account data is correct, we will have slot information and account information. Slot information is essential. It's number of slot that is going on the blockchain. So we will keep it as a variable, and I believe it's string. Yes. So we need to do conversion. Great. So now we have a slot and we have account data in it. It has owner, which will be our token ID from Solana because it's a SPL token. We can check it like so. If owner equals to token ID, yes, token program ID. In case if it not equals, we will return. So we don't care about any event that is not related to tokens at all. This should be converted to the string like so, and this we should, oh yes, I forgot. If account is not set, we will also return. So we can remove this. Oh, and we need to convert it from array into string as well. So base 51 encode like so. So what we did here, if event is not related to account update, we just ignore it. We just return and do nothing. We get slot from payload that Yellowstone sends to us. If there are no account payload, we just ignore it. If owner of this account is not token program ID, so it's not a SPL token, we will ignore it as well. You can see import is from SPL token program here, from Solana SPL token. Okay, I will go ahead. Now, interesting part, data. So we have a data payload from the Yellowstone to us, and it's array, it's raw data, it's just bytes. We need to transform it in the way that our program will understand, so basically unmarshal. For this, we use count layout from SPL token, and we need to decode it like so, and it should be buffer from event account data. And that will be our message. That was the hardest part, to be honest. So we have already the message, which is raw account data. We have a slot data, and that's everything that we need to unmarshal. Just 5 lines of simple code, and we have to put now the core logic of our application here. So let's do it. In message, we have amount of transfer. We have mint, which tells which NFT we are working with, and owner. This owner is different from account account owner. It's within message. So token program works with messages, and this is owner of NFT or coin. So this will be address, and we need to make it as a string for simplicity. So this is address of user who either bought or sold our NFT. Now, to determine whether he sold it or he purchased it, we will just check active balance on his account. We're basically looking for account balances change, and if it's 0, it means he sold it. If it's 1, it means he just bought it. So we will do switch case here. As a key, we will use message amount, right? First value will be, is it big int? Yeah, it's big int. So we in case put 0, means he sold. He no longer has any NFT. And another case will be if he just bought one NFT. So let's start with case when he just bought NFT. So what we need to index in particular, we need to index active holders, and we need to hold some of every single allocation that we plan to allocate to this user. For that, we need first go back to the class and create new fields that will illustrate that. First, active holders, which will be map, and type will be string to slot big int. Yes. So this is mapping that will map address to start slot time when this user bought NFT. So we can make a time window and compute how many slots he have held, and we will compute it into allocation. It will be new map, and type will be also string, but as value we will use number, and this will be address to allocation, current allocation. Fantastic. That's it. That will be data that we need to compute here. So when user just bought NFT, we just put it into active holders. We will just set it with address, and as value we will use slot that we have above. Slot coming from here. I think that's it. Yes, we just put it into active slot, and the active holders we put slot information on address, and that's it. Now on cell we need to also get this data, like last slot that he held, and it will be start slot. Fantastic. Start slot will be either begin or undefined. If it's undefined, start slot is undefined, we'll just return. So if we get, for some reason, we will get event of account update that contains no information about start slot, so he never hold this NFT, we will just ignore this event, it's unrelated to us. So here we need to compute delta time. That will be slot minus start slot. That will be our delta time, which is big int, and we should put it into allocation straight away. Set address delta time. and we need to convert it to number. Right. Oh, also, that's not it. We also should check whether he had any allocation prior to that to make a sum of original value. We will get allocation for this address. Right. Current allocation. And we will combine it with delta time that we just have created. So it will be current allocation plus number. And it could be undefined. In case if he never had allocation by this time, we will just default it to 0. So I believe that's it. So let's go again through these events. So if user sold NFT, we will check start time, how long he have hold this NFT before that. We will find this time as delta time. We will apply it to, we get allocation that he has and apply it to combine delta time and current allocation, and that will be actual allocation of this user. That's it. Now let's go on end. Yeah, that's important thing. So we have a lifetime of connection to the Yellowstone, and sometimes either your application stop or something happen with streaming. And when streaming ends, you should do some cleanup or post-processing that you have to do. And in our case, we will have users that was holding this NFT for a really long time and never sold, for example. And if he never sold, we never will go to this case, meaning that we need to do this case on end of lifetime of our subscription. That will look really simple. We will get key and value from active holders, where key will be address, and value will be last slot. So we can make it like this, slot equals to V. And with that, it will be start slot, sorry, start slot. And with that, we can simply copy over this thing here. But you can see that we don't have slot information on end, because end is event on client side, not on Geyser itself. So it's our housekeeping. So we need to have some slot information prior to that. For that, we need to actually track it here. And we will create a field for that, last slot. And it will be also big int. So it will be like this, -1, just to have illustrate that it's have nothing. And if slot is correct, we will just put it as last slot. Slots are ordered, so it cannot be less than last slot that we have. Actually, it can. Yeah, right. That's good point. If, let's just be extra precaution. If slot is bigger than this last slot, we will set it like so. Fantastic. So if slot is bigger than last slot, we will just set the value to last slot. And this last slot is very useful here. We just use it like so. Last slot. Perfect. And now we have a housekeeping. What I forgot to do is to clean active holders dictionary map. And also here we have to remove from active holders this guy that just sold. So we will not get into this situation once again with address. I believe that's it. Yeah. Oh yes, of course. Check allocation should be complete. So this is method that I use in test. So let's try it here. Allocation get wallet, and yeah, by default it will be 0. If user never interacted with NFTs at all, we will just think that he will have 0 allocation. So that's it. So now let's run a test on that and see how it works. So I wrote this test. It has various scenarios, like Alice case that I covered first, and it has a test for escrow. What I forgot, I will just fix it. I have a case of Bob having allocation, and etc. This is tests that I have. I forgot to implement excluded. That is important gotcha for allocation. You have to exclude some parties from allocation. For example, when someone will list NFT on Magic Eden, you should not give allocation to Magic Eden at all, because it's program. He will never be able to claim it. So here, when we get an address of this guy, we will just make if statement that will use excluded, and if excluded list has address that we want to exclude, we just ignore this event altogether. Now let's run the test. One failed. Yeah, everything is failed because I forgot the most important thing. Yeah, I'm sorry. So we did try to decode the message, but we didn't check the message if that message is correct. For that, before we decode the message, we should not only check for token program ID, but also we should check for whether these data fit our account layout. And this is quite simple. It has some quite simple trick. We just need to get length of the data in case if it's not equal to account size from Solana SPL. In that case, we will ignore that event. So if in some case event that come to us is not related to change of account, we will just ignore this event. And with that, we should have all tests green. We don't have all tests green, but at least we have a few tests green now. Let me see. Check location for Bob should be 1, and it was 0, 0, 1, 1. Let's try to figure out what we missed here. So, if user no longer has NFT, we get start slot and compute delta time. In case if current allocation is present or not, we just get it and fall back to 0. And we set allocation for this address to be current allocation plus delta time. And we remove it from active holders. In case if he bought, we set address with actual slot. And on end, address is key from active holders, start slot is V, and we, oh, yes, exactly. That's where is another gotcha. So you have also different sort of internal event, which is slot. And in that case, test failed because last slot was not actually really last one. So we should fix it here. Here, we ignore after this line, we ignore any event that is not related to account, but we also should care about event of slot update, which will work very simple. I believe it will be 3 lines of code. Account, no, slot. If event has a slot and this slot is correct, then we should set last slot to be equal to this slot update, and it should be big int. Yeah, just like that. So if slot is set, we will just use it as last slot return. That should fix it. Let's try again. Boom. Everything is passed aside of one test, and it's now it's intentional to have a failed test. Which test is failed is last test that we have, which check accumulates hold across 2 means held simultaneously by same wallet. So if I was holding 2 NFTs at the same time, I should have a double allocation, not single allocation for mint. And our current version of Indexer does not support that at all. Reason for that we override address. So you bought NFT, you sold it. You bought NFT, you sold it. We don't care for a case when he bought 1, he bought 2, he bought 3, and then he sold 1. This case was not cared for us, but luckily for us, it's just simple fix in few lines, because message from account layout has already mint information of this particular NFT. So we can have it like so, message mint to base 58, which will be same format as address, just some public key as a string. And yes, and we have to do a key that will be something like that. First it will go with address, then new line, and with our mint. What I did here, now I plan to track active holders, not by address, but by a key, which is combination of address and mint. So we can track hold of NFT across one wallet, but different NFTs. Before we was just tracking different wallets. And now we have to do search like this to find every occasion when we check active holders and check it to use a key. Here we will use a key. Here we will use a key. And here as well we will set it like so. And now hard part about active wallets holders. Let me guess. Yes. We will just split it by a new line. It's not perfect, but it works for the demo. And we will get first element, which is under index 0, and we will make it forced. First element will always exist. We don't need to change start slot. I believe we don't. Yeah, we don't have to change this part because just clear. And with that, test should be passing. Let's see. Hooray, everything is green. That's great news. I will speak about this test also to cover Yellowstone mock that we built with getBlock. So you create a mock that will play events that you pushing into that. So you will push event that Alice minted this NFT and then another NFT, and then she transfer this NFT to Bob, and then she transfer another one to Bob. We push slot update and end the streaming. We will connect indexer, our famous run boilerplate function, and we will check allocation for Alice and Bob, and it will be 6 and 4, just because she minted it and held longer than Bob did, and Bob didn't mint it. So that's it. Now, quickly, how to use it in production. So that's test passes. Everything is all right. I will not remove QR code. I will push it to the GitHub so you can check it as well. That's push. Use this QR code to get to this repo and check this code. It's actually great boilerplate for you because it has everything that you need to start. It has also mock, which is quite useful. And if you use code agents, it also has Claude skill installed and agents skills for Metaplex that will help you to decode events. So Cloud Code will care everything for you. And it have also documentation on board from GitBlog about Yellowstone and about mock. So you just tell Claude, please fix everything, check docs, and he will do everything, showing QR code back.
Can you share a QR code because we can see it?
Yeah, sure. Here it is.
No, you don't share a screen.
Oops. Yeah, let me share the presentation. Yeah, here it is. You should be able to see it.
Yes.
Right.
Yes. We have a question. Mohammed, yes, you can ask.
Sure, you can ask whether with voice or in chat, as you please.
Yes. I think maybe it's a mistake. Yeah.
Oh, yeah, okay. So yeah, right now.
Yes, we see something in the chat.
Oh, yes.
I can read it for everyone. Okay.
Yeah, please.
Okay. Since each Yellowstone plugin sits on a different validator with different turbine 3 position, does it make sense to fan and form multiple endpoints and deduplicate to get earlier, more complicated data?
Yeah. Wow, that's really tricky question and smart idea. So, as we covered before, you have a slot that is not confirmed, which is processed. It was just processed. And based on leadership across validators, you will have different data because you're not behaving a little bit differently than another one. And if you have like max I would say yield from that, you can have multiple nodes and funnel into not one, but different application, like copies of your application, so to have some advantage. For example, you can distribute it by region, and you could even like trick it and put it as close as your actual node as possible where it's running, and that will help you to get earlier events and insight for block that was just processed, so you will be like physically closer to that. That's a great idea. I wouldn't funnel it into same application per se, because it will make your application the bottleneck here, and it will get your application overflooded with deduplicate events that you have to deduplicate. But instead of that, you should do some story like distributed things. But it's like tier A level, I would say, of using Yellowstone. Fantastic question.